Right. So what we're going to do now is we're going to get into some digital technology for surveying. So I'm not sure how many people here have either played with or used a drone, but what I'm going to show you now is how we're using drones and laser scanning for our construction projects. And I'm not joking when I say this is transformative technology. We have seen immense value from these technologies. But what's important in what I'm going to show you now is that this was started as a top-down approach where a number of people, myself included, were promoting the use of some of these technologies. But what we did was we showed some key people what was possible, and then we invited them to take it on and drive it. And what has transpired is that the head of surveying for Gamuda, he is a very experienced, he's not young, he's probably in his late 50s. He has taken on the role of allowing his surveyors to be trained to become drone operators. He's taken on the role of allowing people to use laser scanning. He's given all of his staff iPads, and he's demonstrated immense savings in terms of their time on site and their accuracy in the information they're providing. So he has taken an idea and run with it. And this is what's really important, is that we need to find the existing staff in these corporations, whether they're contractors, engineering firms, architectural practices. We need to find the leaders of those companies, get them inspired, and get them to drive their teams to change. And this is a brilliant example of it. So there's no way that a technology guy like me sitting in a major corporation could have affected the kind of change unless it was affected by the actual head of surveying. So let me show you what they've been up to. So the guy I'm speaking about is this guy in the top corner. This is Pois. He is basically the head of the chief surveyor for Gamuda Construction. And given the scale of our business, you'll understand how important that role is. This is one of his team on site with an iPad. This is one of his team playing with a VR headset. And this is Tony Joseph, who's our DevOps. Tony is responsible for the back end of all the systems that I'm going to show you. So he's been writing code. He's been setting up GIS platforms. He's been setting up Amazon Web Services, Microsoft Web Services, you name it. Anything with ones and zeros in code, Tony is all over it. Their job has been to connect BIM to the construction sites by whatever means necessary. So I'm going to show you some examples of what they've done. And the first example I'm going to show you is laser scanning. So we have done a laser scan survey. Let me get the video. So this is a laser point cloud scan of the same Tiddywanksa station I showed you earlier on. We've done this for every single construction project. And we've used the laser scan survey to build a reference model in Revit for the design consultants. So in this case, as a management contractor and a design and build, we know how complicated these interfaces are going to be. We know how important it is to get the geometry and the surveying correct. So a traditional surveyor will give the design consultants a two-dimensional drawing. In our case, what we've done is we've gone out on site and we've used laser scanning to create a point cloud mesh of the entire environment that we're working in and around. And then we've identified all the key structures that we're going to interface with. And we have then modeled those and given those models to the consultants and said, we're not giving you traditional 2D survey drawings. We're giving you a 3D model that's referenced to the data in local grid. So it's referenced to the actual survey grid. And we want you to use that model as the interface tool. So when you model connecting bridges, when you model connecting underground structures, you have an accurate reference 3D model. So the first thing we've identified is the use of scanning and modeling as a way of demonstrating as-built and conditions. So the next thing we've done is we've taken that to the next stage and used drones. So I'm going to play you a video, and the video is going to basically, it's got its own narration, and it's going to show you how we do image capture by drones. So let me set that up and I'll play it for you. And then after the video, we'll take some questions. Our team use software applications to plan and control each drone flight. The drones can quickly cover a large area of a site in a controlled manner, collecting hundreds of overlapping photographs in less than an hour. The drones operate at 60 meters to 100 meters above the sites, and they can also operate at lower elevations where we need to get photographs of activities inside the site. Here is an example of the drones flying over 2 TBMs. These are about to be launched for the 2 southern tunnel drives. Safety is our priority. All of our pilots and spotters have been trained to use launching pads in a safe, confined area away from site activities. The drones, batteries, iPads and controllers
are thoroughly checked before each flight. Here you can see the pilot assembling the drone and checking the propellers. The pilot turns on the drone to make sure it's properly connected to the controller and checks it has acquired the GPS satellites. For every flight operation, we assign a drone pilot and at least one drone spotter. At the end of the flight operation, the team makes sure the drone returns to the designated area in a safe, controlled manner. The drone pilots are identified by a specific safety vest, and they are responsible for the safety and operations at all times. The drone spotters keep a track of the drones and the surrounding airspace during all the flights. They are in constant contact with the pilot and the site safety manager. In order to ensure that the survey photographs are tied correctly and accurately to the local Cassini grid, we use sets of 3 to 4 ground control points for each survey. The ground control points, or GCPs, are recorded using GPS coordinates by one of the surveyors, and these are needed for the photogrammetry process. A common use of drones is the production of orthomosaic photos. This is the tunnel alignment between Chan Sao Lin and Bandar Malaysia North. The ortho photos are used in GIS and are of a higher quality and more accurate than publicly available data. Here you can see a typical image from Google Maps or Google Earth, and if we overlay our orthomosaic photo, we can see the difference in quality and accuracy. We can very precisely position the TBM underground in relation to the above ground structures. Drones save us a lot of time in creating accurate ortho photos for mapping. The drone surveys are used to generate 3D models of each site. In this series of models, from July 2017 to April 2019, you can see the site progress in 3D for Bandar Malaysia North. A traditional time-lapse from a fixed camera position looks like this. It provides a good visual record of the daily site activities, but we cannot use this for surveying or for measurement. The drone surveys do allow us to do a lot more than just look at visual information. You can see excavation works, the TBM assembly and launch, and you can see permanent structure construction. The sequence of models taken over this 18-month period is a very useful way of looking at progress over a longer period of time. As they are 3D models and not simply photographs, these site models can be used for measurement and analytics. This is the Chan Sao Lin construction site. This is the context capture model from April this year, and we can see the TBMs have arrived in the station box excavation, and you can see the construction of the permanent works are underway. The 3D model derived from the photographs, surveyed using GCPs, can be reviewed and compared to the design BIM information. Here we can see the station box walls have been constructed in accordance with the design. Using the design BIM information, we can overlay the structural BIM for the station box with the drone survey models to review the excavation sequence in relation to the station design. We can monitor and assess the construction progress, and we can demonstrate the site condition in comparison to the design layout. The image on the top right is the photogrammetric 3D model, and the main image is the design model for the station base lab combined with the excavation sequence. This is very useful to communicate with and share with the design engineers so they can see what's happening on site in relation to their design. We use the models extensively for measuring as it saves us a lot of time. In this example, we completed a drone survey of the piling works, and we can measure the length of a section of the constructed secant pile wall. The 3D models are also very accurate for measuring volumes. For this example in Chan Sao Lin, we will determine the cut and fill required to create a platform at 28 meters. We first identify the boundary for the area we want to measure. When the boundary is marked in the 3D model, we fix the measurement plane at 28.5 meters and set the density of points at 0.75 meters. We need to cut 11,300 cubic meters in yellow and fill 9,800 cubic meters in green to form a platform at this site location. Drones enhance our safety procedures. If an area is inaccessible or unsafe, as in this example of a slope collapse, rather than sending staff to investigate, we can use drones to safely conduct a survey. This allows us to plan our work safely and identify the risks before workers enter an area of the site. The drone surveys are readily available to all of the project teams via our online cloud platform. In this example, using a web browser, we can identify all of the available survey data. Each site model is available online and can be viewed via the internet. The BIM data for each station is available to be viewed with the drone survey data. Our drone surveyors recently demonstrated a fun and innovative way to use the drones for construction. For the first TBM breakthrough, a major milestone for our project, the survey team used drones to safely give everyone a bird's eye view of the tunneling works. The video was streamed directly from the drones to our social media channel, and hundreds of people watched the construction activity live online. We are very proud of our drone survey teams. We have a large team of trained pilots and spotters to safely operate drones and conduct flight operations across all of the sites. We have dedicated drone survey teams at Central West. The team at Titiwangsa are very proud of their drone survey roles. We have a happy survey team at Hospital KL. The large team at Kampong Baru, Ampang Park and KLCC East are proud to show off in front of the KLCC towers. Here the team from Conley and Chancel Inn are having a fun moment with their drone. The team from the Bandar Malaysia North and South stations helped compile this presentation, and our tunnel survey team, who believe drones are now a key tool for their work. Gamuda Engineering are committed to using drones to improve site safety, construction productivity, and enhance our surveying capabilities.
That is a video that was produced in late last year, and like I've said earlier on, it was used to promote what we're doing as a corporation, but it was mainly used to actually motivate the staff and get them to understand what was happening and to recognize those that had done the work. So if you would like to learn more about it, there is an article which is on my LinkedIn page, which I'll send you a link to on the chat. So on the article, we actually go through the process for doing this. So we go through how it's integrated with BIM, how it's connected to GIS, and we actually go through some of the key things you need to consider when you're setting up these drone operations. So you've basically got indications of elevations you can operate in, how you set up ground control points, how you can use the meshes for, and basically you can see a presentation we actually gave in Singapore for the award that we picked up at the end of last year. The reason I'm sharing this with you is we don't believe enough people understand how to use drones for more than just taking pictures. So most people know how to use drones to make a video, or most people know how to use drones to make a picture, but we want people to use them for much more than that. So if you haven't already figured out how to use drones for surveying, then feel free to read this article. And if you want more information, I can connect you to Mr. Poa and his team, and they will be able to give you more information. So does anybody have any questions on that use of drones? Yes, Wing.
Can I just ask a very basic question?
Sure.
So about all these info and videos and pictures,
yeah,
would that constitute like a very big, like a storage issue, basically?
No, so you're right. It creates a huge amount of information, but the technology systems that we have can cope with that. So essentially, when we do a drone flight, we capture hundreds and hundreds of images of high resolution, and those images are stored on an Amazon web server. So we actually put them on the cloud as quickly as possible. And now we're actually working with Bentley, who provide this context capture software, and to convert the photographs into the 3D models that we can then use for integration with BIM and integration with GIS. At the moment, we've been using local PCs, so we actually use high capacity machines locally. We're actually working with Bentley to come up with some cloud solutions so we can actually render these things in the cloud and speed up the process. So this is still a growing and developing technology, but because of our use of the cloud, and we basically operate on a no limit storage capacity on the cloud. So the amount of money it costs to store data in the cloud is insignificant compared to the value of these processes. So it does create huge volumes of data. It does create terabytes of information, but the cost of storing that information is minuscule compared to the value that's adding to the process.